put as many questions as you like in. I can't promise I'll get to them today, but we'll keep a text record of all of them. And I'll either tweet out answers or I'll put them in a blog post. But let's get into it. Now, you will notice that my virtual background will slowly change throughout this presentation. The reason I wanted to do that was it's such a shame not to actually be in South America with all the good friends I've made over the last couple of years. So some of the photos I've taken over the last 2 years will slowly work their way through. That's the closest I can be to being there. So I'm from Perth in Western Australia, which is here. And I used to put up pictures of this slide and then show pictures of the bushfires, because at the start of 2020, that was the big international drama, bushfires in Australia. Things have changed a little bit since then, I can imagine. And so I just wanted to put this slide up there, not to create gloom and doom, but really just to remind ourselves that whatever your local bylaws, restrictions, etc. are, please abide by them. Please stay safe, because community events like this one only work if we actually have a community. So I'm hoping that by 2021, we'll be seeing each other face to face. And also that will avoid me needing to get up at 5 o'clock in the morning to do talks for South American time. I'd be willing to bet I'm the only person here on Tuesday. The rest of us, I imagine it's still Monday. So this is how you get in touch with me. Please follow me on Twitter and reach out to my blog, or if video is more your thing, I've got about 300 or so videos on YouTube, tech videos. So I like exploiting all the forms of social media. So why tips and techniques? It seems an odd topic. Normally we talk about just one thing on a single presentation. Here's what happened. Here's the motivation for it. I was doing my normal job, which is answering Ask Tom questions, and someone, if I zoom in, asked this question: how do you pass a parameter to a view? And I gave them an answer, and the thing is, eventually they came back to me and they said, how did you know that was the answer? How did you work it out? And I wasn't trying to be nasty to them. I said, it's just one of those things I had to work out years ago, and so I had the answer readily available. I just said it, just sort of experience, I guess. It's that experience of being in the Oracle space for 20 plus years. And that was my honest reply. I wasn't trying to be insulting. And they came back to me with a review and they said, yeah, we think you're an asshole. So I thought that was a bit brutal, but I could understand their mindset. Yeah, maybe they were right. Yeah, I certainly hope not. But it is that thing of, a lot of the times when we give answers and Ask Tom, it's just because we know them. It's not because we're brilliant or geniuses. It's a problem we've encountered in the past, had to solve, and we now get to take advantage of that knowledge. And this is the key thing. One thing I've noticed a lot in forums lately, Stack Overflow and the community forums, etc., is we tend to be very critical of those people that don't already know the answers. If someone asks a question, we often say, no, you should just, RTFM. Why don't you just Google that? And I don't think everyone should have to reinvent the solutions to problems that are already solved. Now, don't get me wrong, people shouldn't be lazy, but let's face it, why do we have events like this? The objective is about sharing knowledge. This is about building a community. And just telling people to RTFM all the time doesn't build that community. It's not a generous position to take. So I think if we have picked up tips and techniques, our duty is, no matter who we are, is to share them with the community. And that's what motivated this session. And that's why I wanted to talk about it. Now, there is a safe harbor statement. You'll be pleased to know that you won't see many of these anymore from Oracle people. We've been given the permission not to use them unless we specifically have to. The reason I have to in this talk is there's a few things here which are actually unsupported. Now, don't forget, I'm giving this talk to you from Australia. That is the place where most of the world sent their convicts to in the last 200 years. So please don't trust me. Anything you see in this talk, test very carefully, make sure it's appropriate for you, and then use sparingly. But a key thing here is, if anything you see today is not in the documentation, before you use it, have a chat with support, make sure you clarify the usage before actually proceeding. Some of these things are just tips and techniques that are not officially supported, but are commonly used. But it's important to get the nod from support, otherwise you're on your own, hence the safe harbor statement. So we're just gonna go through as many as we can in our 45-minute allocation, and we'll see how many we get through. So the first one is dealing with rogue sessions. This is a common thing we have to face as DBAs. We log on, we look at $B session, and we see one session there, and the last call ET stands for how long that session has been in its current status. So it's been active for over 2 hours. And the funny thing is, often when a session has been running that long, the person running it, is prepared to wait, because no one is prepared to wait that long without actually preparing to wait longer. They're not the people that are actually most upset. What often happens is it's other sessions that would normally be very, very fast that start to slow down because the one bad session, session 39, is chewing up all your resources. He's absolutely destroying your CPU. So the phone starts ringing not from him or her, but from the other people going, the server seems a bit slow. What's going on? Now, in the old days, what would happen is this always happens, of course, at 2 in the morning. And if you're of my generation, you would remember you would wear this thing called a pager. And a pager would show that you have like an idiot in the database, and you'd crawl out of bed and you would try to sort of start, kill that session off. Obviously, things a bit more modern nowadays is, the same thing happens. You just get the same thing on your phone. That's the only real difference. But either way, same thing happens. We crawl out of bed, we do alter system, kill session, or we kill it at the operating system level. But of course, what happens is that gets you very upset users, because that person who was waiting for 2 hours to get their report is now going, well, I now have to start the thing again. And in reality, what we don't want to do is kill that session. Really what we want to do is make sure that he is not causing problems for everybody else. So here's a technique you can use if you get called out late at night. You log on AssistDBA and run Aura debug. You set your Aura PID or your OS PID to the session that is currently running for 2 hours. Having done that, what happens is you run Aura debug suspend. That freezes that session. He no longer can do any IO or CPU calls. He'll just sit there and do nothing. Because you've now freed up all the resources on the server, these other sessions get a chance to finally get all their work done. You've effectively given them their slice of the server pie back again. Now that they've got their work done, you can resume that session and let him continue on. As a result, they'll never know that they were actually paused for a while. They just seem to maybe take 10, 15 seconds longer than they thought, but they'll never know that. But that way you haven't actually killed the session. You've simply paused him for a second while everyone else gets a bit of a slice of the pie. Number 2, you get the idea. We're just going to fly through these. Please don't panic. You'll get the recording and all the slides as well. Now, maybe it's not bad SQL. Maybe the reason this person has been sitting there for 2 hours is because they've been blocked. And you can look at the lock wait column in VDollar session to detect if you're actually on a blocking lock now. And if we actually build upon that query and go look at some of the blocking session columns and join that into VDollar SQL, you can often see, for example, here, session 46 is actually been stuck for 2 hours because he's blocked on session 39, who is doing, and session 46 is trying to do a select for update. But because session 39 has got an outstanding lock, it's that classic scenario where someone has started a transaction and disappeared off for lunch, for example. One of the things I'd recommend to have in all your applications is, rather than select for update, do select for update and nominate a wait period. This came in way back in Oracle 9. For example, wait for 60 seconds. In that case, you'll try select for update, you'll wait for up to 60 seconds, and then you'll get an error, Aura 30006. Note, it's not the same as the standard lock error, which is -54, which is when you try lock and timeout. It's a different error message. But what's the difference? Who cares? I still had to wait for 1 minute. It's still a frustrating thing. The real difference is forever is a very long time. If you do select for update, you will literally wait for as long as it takes. And the key thing is, when you're prepared to wait forever, you have this thing called cascading locks. It starts off something like this. This is bad in itself. Session 39 has been waiting for session 39 is inactive. He's the person that has the lock. But then session 46 and sessions 56 and 58, they're also blocked, all waiting on session 39. They may have locked a critical resource. But for example, those sessions there in the blue color, they may also have outstanding locks. So then the fact that they're waiting causes other sessions to lock. Now 62, 63, 67, they're waiting on 46. And because those sessions are locked, it's possible that other sessions then lock on those sessions. So when you're prepared to wait forever, you can get these cascading disasters of hundreds of sessions all blocked, all because one got stuck. Because it's a nice different error message, it's a different error code, one of the nice things you can do is when you do timeout and get error 30006, you can capture that with the DDL trigger. And I've done a simple one here where after server error on line 2, on line 6, if it's a 30,006 server error, then for example, I could do things like go find the session that's blocking me, looking at the blocking session column, look up, for example, the OS user, maybe find their user ID, pass on their details. So now it would look something like this. I try to do a select for update wait 60. I will get that error after 60 seconds. The server error trigger would say, oh, it's Connor on phone extension 1234. He's causing you problems. I call that empowering the users, because now the users could phone each other and say, hey, get off the database, or commit your session. And it solves you having to get up at night in the middle of the night as a DBA. Number 3, triggers. Now, when it comes to coding triggers, I'm not the best of them. I used to do a lot of coding when I was initially an Oracle developer, but I've moved more into the DBA space over the years. I still like to think of myself as a bit of a developer, but especially as I get older, my memory is not so good. So when I create triggers, I might create a trigger something like this, which is checking my salary on a Monday. The code doesn't really matter. What does matter is the moment I go to compile it, generally I'll get an error on the first try because I've spelled updating incorrectly. And that's no problems. I'll fix that, change it to correct, and then I get the next error. I didn't put the colon in front of the new column. And then I go, okay, let's try fix that. Oh, then I get the next one. I put end where I should have had end if. And I'm sure we're all the same as this. We simply go through the process of fixing up the compilation errors until the thing is finally compiled and correct. And we go on and we go on, we go on. Now, for any other piece of code, that's normally not a drama. But for triggers, it's a big deal, because the moment you have a trigger which won't compile, anything on the table that trigger is being built on is dead. You've literally broken that table, because the moment you try do any updates on that table, you get this error. Trigger is invalid, it can't be compiled. You literally have broken all DML. And when I say you've broken DML, it literally is all DML that the trigger was nominated against. For example, if I try to do this, now I'm doing an update here for an employee that does not exist. So there is no row with employee 7365. So even though that trigger would not fire because there are no rows, it still gives you the error, even though there is actually no row to be updated. Just the fact that the trigger is invalid and you've tried to do an update and the trigger is on an update immediately blocks all DML. You simply, there is literally no data for there, and you still get the error. The way to fix this is, my recommendation is you should have a company standard, which is you always create triggers in an initial state of disabled. That came in Oracle 11. You create your trigger with a state of disable, and now you can go through that process of fixing up all your compile time errors, etc., and it causes no harm. And then when the trigger finally compiles, and you're hopefully happy with the logic it contains, then you simply do alter trigger enable, and then the trigger is activated. That way you never run that risk of having an invalid trigger in your production systems. So my scripting advice would be you create your triggers as disabled, and then you can simply loop through at the end of your installation, making sure all the triggers are valid, and then enable them. Number 4, tracing. A lot of us get involved in tracing when we're trying to fix performance problems. And tracing is literally the definitive performance analysis tool. If you've read any Karen Millsack's blog posts on Method R, it's a fantastic facility. It's probably the best SQL tuning or performance tuning mechanism there is. The problem is, once you get everyone excited about tracing, sorry, something has popped up in the chat window. I'll just make sure that it's good. Oh, that's okay. Just a nice message of support. Once you encourage your developers to get into tracing, which I can't stress enough, it's a fantastic facility, you end up with this kind of problem. You have thousands of trace files, and as a developer, your job is to try find them. If you have too many trace files, a common technique I like to advocate is to use the trace file identifier parameter. The moment you set this, your trace file gets that in its file name. So now when you look at the trace files, I did trace file identifier equals, I was tracing the sales program, it actually appears right there in the file name, makes it very easy to find. The other benefit of that is every time you set that to some new value, the existing trace file is closed and a brand new trace file is opened. So if you have a long program that does different sets of functions, you can alter the trace file identifier throughout that session to get different trace files so you can hone in on the right data. Here's a bonus tip. If you don't know your trace file name, one of the nice views that came in more recent versions is $diag info. You query that and it tells you what your trace file name is, where your alert log is, where the trace files are stored, etc. It's not the 3 dots you can see there. I just wanted to fit it on the screen. It is the fully qualified name of your trace file. Number 5, let's continue on with tracing. You've turned on tracing for this 9-hour batch program. You get an enormous trace file. The problem is, often we're tracing something to find out why something crashed. Now, if your 9-hour batch program crashed at the very end, you probably don't need the first 8 hours of trace data. You just need that last bit of trace file data at the end where the thing crashed, because no one wants to look through a 100 gigabyte trace file. You can do this. You can do alter session set events immediate name trace buffer. Now, the number you provide to that buffer is actually the size of the trace file that will be retained. So in that case, that 1040856 is a megabyte. So at the end of your tracing, we keep the rolling last megabyte of trace data. So you might trace for 2 or 3 hours, but still we only ever get a 1 megabyte trace file, and it's just the last megabyte. We simply keep that rolling buffer. That's a great way of keeping your trace files down to a small size. One last little bonus is if you don't have access to the operating system, which is common now in the cloud environments, in a lot of those environments, you can now view $diag trace file content to actually get the trace file contents. You can spool that out to your local machine, run tkprof on it there. So just because we no longer have access to the OS, typically in cloud environments, doesn't mean you still can't take advantage of tracing. Number 6, this is a 19C one. You may have heard a lot of the fanfare about automatic indexing in 19C on engineered systems and autonomous database, and I'd be very surprised if you haven't seen this slide at some stage in the past 12 months, where we monitor the system, find candidate indexes, apply them, test them, make sure they're actually doing a benefit, use some SQL plan management to make sure we don't get regressions. It is a super, super cool feature. And of course, everyone goes, that's great, but I'm not on 19C yet. I wish you all were. It's definitely the place you want to be upgrading to. But obviously, I live in the real world as well. A lot of you are on 11 still, a lot of you are on 12, some are maybe even on 10. So until you get to 19C, what happens when someone comes up to you, whether it's a developer or another DBA or et cetera, and says, I'd like a new index on my 6 terabyte table. And you know that's going to take a lot of time to build, and it's going to consume a lot of space. So you'll probably push back and say, is that definitely going to speed things up? And someone's going to say, well, I think so. Now, I'm not being critical of the person making that request. The reality is the days of having good sized test volumes and development volumes that match production seem to be a thing of the past. One of the things that happens nowadays is, which I find very sad, is we see very tiny development systems with just, hundreds of rows in their systems. And yet we expect our developers to produce beautiful code that we know will run great in our massive production systems. It really is impossible to tell. I find that a real sad thing. We should have large volumes in our non-production environments. So when someone says, I think so, that's a genuine response. How do you really know if an index is going to help if you don't have the volumes to test it with? This is where virtual indexes might come in useful. You can create an index and say it is a no segment index. You can think of it similar to being an unusable index in the sense that the definition exists, but there is actually no physical index sitting behind it. It's just the database definition only. Obviously, it can't really be used because it is not a real index. It's just the definition. What you can do is tell the database to generate some statistics. Notice that's not a gather command, it's a generate command for the table which you've just created this index on. It will use the table statistics and the column statistics to try to come up with some representative stats for the index statistics. It can't really gather index stats because the index doesn't really exist. Now you can turn on a particular session parameter called use no segment indexes. Now we can't really use a no segment index. It doesn't really exist. But what happens is that's telling the optimizer to assume that index is really there. So then I can run an explain plan on my query. This is the query I was trying to speed up. And now I get what's called a virtual execution plan. This is the optimizer saying, if that index was really there, would I actually use it? And this is one of the things that goes on under the covers in our automatic indexing. And you can see there it says, yes, that index called test would probably be chosen by the optimizer if it really existed. This is a great way of getting an increased level of confidence that you actually have, that you will use that, get benefit from this index if you actually went and created it in your massive production environment. Number 7 is the logical extension to this, which is invisible indexes. Virtual indexes really are still not enough. And let me explain why. Here's our example. We've got a table called T. It's just a copy of all objects. I'm going to create an index called obj, object index, on the object ID column. Remember that we have an index on the object ID column. So someone might come to you and say, I've got this query which is a problem in my production system. It queries on the owner table and the created column, sorry, the owner column and the created column. And because there's no index on either of those columns, it does a table access full. And so now we're into that scenario we just spoke about on the previous tip. So they said, can I index the owner column? Now, hopefully you'll say, will it speed things up? And from the previous tip, our developer has gone off, they've created a virtual index, they've done a little check on the owner index, and they say, I know so. I'm very confident that if we put the index on, it's actually going to have some benefit. So we go ahead and create this new index. I can see I've created an index called new index on the owner column. There's the query that was using the owner column, and now it uses that index. And everyone's happy. The developer created the new index. It seems to have some benefit. We all run around and we're giving each other high fives until, of course, the phone rings. Because adding an index is a massively risky thing to do. Because yes, that query on the owner column has got fast, but everyone else's queries, well, they may have gone to a brand new place. Because before the new index was created, let's look at a different query. Here is someone else's query that was running perfectly fine. They had a query on the owner column and on the object ID column. Now this is before the owner index existed. So it was using that index that was pre-existing called the object index. And that query was costing about 700 IOs, 784 consistent gets. After the new index, we created an index called new_index on the owner column. That query switched over to using the owner index. Now, this is not the query that the developer came to us with. This is just an existing query in our application. It flipped over to using a different index. It now has a different performance characteristic. And unfortunately, it's a slower one. This one is doubly expensive. Now it's 1,500 consistent gets. That is the risk. Adding an index is a massively risky activity on any database. Once again, our users can get very, very unhappy. Now, what's the solution? The solution to this is what I call invisible indexes. And once again, this is something that happens in our automatic indexing. If I'm going to create a new index, I would recommend you always create it as invisible. Because now that pre-existing query that was using the object IX column keeps using the object IX column. Sorry, index. I've got to get my words mixed up. So it is unaffected by the new index because it can't see it. So all your existing queries are running exactly as they were. Of course, your developer says, well, but that doesn't solve my original problem. I wanted to add this index to solve a particular problem. What about my code? What you can, here's his code, which was using the owner, and it's gone back to doing table access full. What you can do is at session level is tell the optimizer that just in this session, I'm allowed to use invisible indexes. And now this problematic code now will see the new index. So this is what I'm recommending. Whenever you're creating an index, you should wrap your SQL to protect others. At session level, activate invisible indexes, or there's even a use invisible indexes hint. In that way, you create a new index as invisible, And those particular areas of problem code can use this hint to see the invisible index. No one else is affected. And then over time, you can look at making that index visible after you've done appropriate regression testing. So this is a great way of, I need an index in a hurry, throw it in there, make it invisible, fix the problem. And now that gives me time to do more regression testing to make sure it's not going to make other things in my application slower. Number 8, better data guard use for free. And I want to stress this is for free, because if you're using a data guard system, you've already licensed the CPUs in which that data guard database is running on. But a lot of us have data guard nodes and we do nothing with them, which I find a terrible missed opportunity. It just sits there in recovery mode, just rolling forward, waiting for that disaster that never comes. One of the cool things you can do with your standby database is run this: alter database convert to snapshot standby. Now, what does that do? It actually opens your standby read-write. It is like a DR scenario. It breaks the link with production, and your standby database is now a standalone database in its own right. Now, that might sound a bit worrying because you've broken its link with production, but please bear with me. Let's say you do that at 8 o'clock in the morning. That database is now a copy of your production database as it was at 8 o'clock. It is read-write. Think of the things you can do with a read-write copy of your production database that is not your production database. I could gather stats on it rather than doing it on production. I could take a backup of it. I could test out an application deployment. I could test out some invisible indexes. I could test out some virtual indexes. I could do ad hoc query for any end users that want to have access to production and they're not going to harm my production node. There are a massive amount of things you can do once you have a standby database which is read-write and available for people to do whatever they want. It's almost better than Active Data Guard because it's read-write. They can create tables, they can drop tables, they can do whatever they want. Of course, at the end of the business day, what do we got? We've got a giant mess now because it's no longer a mirror of production. But that's okay. You simply do alter database, convert to physical standby. What happens is the database is closed off. We rewind the database back to 8 a.m., undoing all the changes that users may have done, and then we put it back into recovery mode. Now, how do we rewind those changes? We actually use our own technology. We use flashback database to that point of reset logs where we open the database. And then we put it back into recovery mode. The cool thing is your standby is now just as good as it was before. It's been rewound and now it's back in recovery mode. It's still working as a DR. And even during the 8 hours or 12 hours when you had it open read-write, the archive logs were still being transmitted over to your standby node. So you're not going to lose a whole day's worth of data if you actually needed that standby for a DR. And so I can't stress enough, I would recommend that, get more power out of your standby database. They're a fantastic thing to have. Number 9, faster queries, having your queries run faster with absolutely no changes to the code. Sounds too good to be true, doesn't it? But let's have a look at how we can do this. I'm going to create a very common kind of table called customer transactions. I say it's common because we have almost in every system a table that has critical data based on some sort of grouping, in this case customers, but the data grows by time. Almost all data grows by time, but anything obviously with a transaction date in it, like on line 3 there, is typically going to grow by time. So I'm going to insert, what have I inserted? 10 million rows there of customers. And you can see on line 4, they're just random values to my customers between 1 and 1,000. So I've got 1,000 customers and 10 million transactions, just simulating typical transaction volume. If I have a table of customer transactions, what is the most common query that's going to come in? People come in as a customer and they want to see what their transactions are. That's what we often do when we log on to our banking application or our e-commerce application, etc. So to support that, I have to put an index, obviously, on the customer ID. That's really all I can do. That's the best query I have. Customer 123 comes in and says, what is the highest amount I've spent this year on all my transactions or for all time? They run this query. We've got an index on the customer ID. We'd expect it to be fast, but this is typically what they will see. Their web page will simply hang. Now, why is that? It's doing all the stuff we expect it to do. There's my query. It's using the index I've created. Yet, if I look at the statistics, it's what's that? Oh, 8 and almost 9,000 physical IOs. Now, that seems odd. If I've got an index, why would that be the case? Here's the problem with tables that grow by time. If I've got time going from the left across to the right, as transactions occur, unfortunately, customers don't do what we'd like. We'd like customers to come in and do all their activity at one time, but they don't. Customer 123 is spread out amongst all the other customers. So the likelihood is every single row for each customer of 123 is on a different physical block, because the blocks he was on have been filled up with other customers' transactions as well. But here's a really cool thing you can do as long as you're on 12.2 or above. Quick drink. In 12.1, we introduced linear clustering, in fact, attribute clustering. That tells the database that when the data is loaded, I would like the data to be clustered or grouped in order of customer ID. That does nothing to the data, it just is a dictionary indication. But then in 12.2, I can actually move any table that's a heap table, move it online with no interruption to service. So now all the customers are grouped together based on their customer ID. Now when I run the query, exactly the same execution plan, but look at the performance. It's now only 20 physical IOs because all of customer 123's data is clumped together in the same blocks. Same with the next customer, same with the next customer, etc. Number 10, DBMS X plan. Most of us have used this since it came in Oracle 9, which was you'd run an explain plan query and then you get the plan for it. It's a very cool little utility. But there's some cool extensions in DBMS X plan I'd like to show you. This covers what I call the infamous hint ignoring issue. I have a query like this. It's a join on employee and department, and you can see there on line 1 in the execution plan, it's using a merge join. And a developer might go, yes, I want a hash join. So what's the hint we use for hash join? It's use hash. I put my use hash hint in, and I'm most disappointed when I see that I'm still using a merge join. That's a bit disappointing. And the question is, why? I put the use hash hint in there. We need to understand what use hash means. Use hash means if I'm joining into the department table, because that's what the D in the brackets is, then use a hash join. But that's if I'm joining into the department table. We're not doing that. If you look at the execution plan, we're starting with the department table and joining into the employee table. So if I want to join into the department table, I have to start with the employee table. So I actually need another hint. If I tell the database, lead off, whack the microphone. If I'm leading into the employee table, start with employee, then use hash into the department table, I get the results I wanted. I'm using a hash join. And this is the most common example you see a hint not being obeyed by the optimizer is that you didn't specify enough of them. One of my favorite quotes is, hints are like violence. If they don't work, use more. Just a joke, I stress. So going back to DBMS X plan, how do I know if I have a plan that I like, what is the list of all the hints I need? Well, we have this great thing called the plus outline extension. If I have a plan that I liked, for example, use the hash join plan, if I add the plus outline to my output, I get, as well as my execution plan, an entire list of all the hints I would need to replicate that plan. This makes sure I'm not going to lose any or have the optimizer ignore my hint because I didn't provide enough. And the nice thing is it's in a nice outlay where I can literally just cut and paste that and paste it straight into my SQL statement. Now, don't get me wrong. I'm not saying this is the way you should tune SQL, but often in terms of an emergency fix, I've got a bad running SQL statement. I go find the plan I want, I generate the outline hints, paste that into my SQL, and I've solved the problem quickly. Now I can spend some time researching why the plan was bad. Maybe my stats weren't up to date. I can find the plan I want and I can lock it into place using SQL Plan Management and then remove all those hints. But in terms of a quick fix to solve a problem for a customer, it's a nice, easy way of getting the exact list of hints we want into your system. Okay, we've got a bit more time for a few more yet. Number 11. If you're trying to find bad SQL on your system, the one thing you don't want to do is smash that system with more bad SQL. And funnily enough, that's most commonly what we see. Here is a real common kind of query that people run when they're trying to find the bad running SQL on their system. I'm getting all the queries that have lots and lots of buffer gets, which hammers the CPU, lots of executions, which might mean the logic is bad, or lots and lots of disk reads, because they might be hammering our IO system. And I'll go query $SQL because that's where the SQLs are stored, right? Well, it's a bad query to run because $SQL is effectively your library cache. If you're hammering away at a massive library cache, then what happens is you are harming other people who are trying to get queries into the library cache. We have to protect that memory structure. You can do better, but still get the same information. If you query $SQL stats, which came in Oracle version 10, that is a replica structure to $SQL. But it is not the same as when entries go into $SQL, they get copied to $SQL stats. But $SQL stats is not the library cache. So you can smash away at that as much as you like without causing any issues. And in particular, it is a latchless structure. You can query it without taking latches, unlike $SQL. In fact, in the documentation, it says it is faster, more scalable, and has a greater data retention. So things may disappear from $SQL and still be in $SQL stats. So most of the time, it's pretty much a drop-in replacement. Look for your queries against $SQL, and you can probably change them to $SQL stats and get some benefits and reduce harm on your system. Number 12, SQL plus hashtags. And no, I'm not talking about Twitter, but please follow me on Twitter. SQL plus hashtags are very, very cool. Because as I said, I've been using Oracle for a long, long time, and I'm starting to get pretty old. So when I'm writing queries like this, select salary from the employee table where, what's the column for what they do? What's the column? Is it job? Is it employee, task? I can never remember the damn columns. Now, normally I'd have to stop my query, run a describe, but did you know that you can run a SQL plus command just by prefixing it with the hash command? So if I don't know what the column is, I can literally, as I'm typing, just do hash, describe the employee table. It's the column is called job, that's right. And I haven't lost my buffer. I can literally just keep on typing and my query runs. The most common example is I'm doing a bit of PL SQL here. I'm doing DBMS output, and what have I forgotten to do? Set server output on. Rather than have to abandon that, I can simply do hash set server output on, just run a SQL command straight there in the block, and then continue on, and out comes my output. So if you ever need to run a SQL plus command, spool on, set server out on, set line size, etc., don't feel you have to abandon your query. You can actually just do it in line and continue on. Probably time for a few more. Number 13, SQL plus SQL CL transaction safety. We've all done this from time to time. I'm doing something that's very, very serious. In this case, I'm doing delete from my really important table. And as I said, I'm getting a bit forgetful in my old age. I've forgotten the where clause. And I start it running and I go, oh no. Now, as we all know, as IT professionals, when something like this happens, you pause, you take a deep breath, and you remain calm. Of course, none of us do this. We sit there and go, oh no, oh no, oh no. I have to kill this before it finishes. So we grab our mouse and we race up and we hit the close button. Unfortunately, just as I click, it finishes. And as I close, what does SQL Plus and SQL CL do by default? They commit, and my data is gone. That's a real unfortunate thing, obviously. However, there is a setting you can use to control that. This came in, I think, in Oracle 11, set exit commit. Now, I stress it defaults to on. Now, we had to do that because of backward compatibility reasons. A lot of people probably rely on the fact that SQL Plus will commit when you exit the session. They may have scripts that assume that the commit will take place. So we couldn't change the default because in Oracle, we are very focused on backward compatibility. So what we do is, in your login script, please put set exit commit off. And that way, if you ever have something that ran away, you just have to kill the session and we roll back anything you don't explicitly commit. Let's see if we can squeeze one more in. Number 14, index compression. Now, before anyone panics, I'm not talking about anything here which will cost you additional license fees. Index compression, basic index compression is free in versions of Oracle. And most of us are familiar with this. If you have a composite index, an index with more than one column, you can nominate the level of compression for the leading columns. And what we do is, if I've got compressed 2, like you can see them in the demo, we go look at column 1 and column 2, the first 2 columns, because we're compressing 2. And if we see repeated keys, repeated values in those keys, then what we do is we can come up with a more efficient way of storing those repeated keys in the index blocks. Instead of storing 10 versions of the same key, we might store once and then an occurrence factor saying it occurs 10 times. It's just a way of removing duplicate keys in our index blocks. So the indexes are smaller. The good thing is by compressing what I mean by is removing duplicates, those index blocks now can contain more data, which means they're more dense, which means you get more value out of your buffer cache. More of your index fits in the same amount of memory. And there's almost, I can't think of a single drawback to having this. It's basically all benefit, no real cost. The CPU overhead is negligible. So why you should pretty much do it on almost any composite index where it makes sense to do so. But of course, the big question is, which indexes? Do we do it on all composite indexes? What if the leading key has no duplicates? What if it's an index where someone's put almost unique values in that leading column? Then we wouldn't get any benefits. How do we decide? You don't have to worry about it. You can actually work out this automatically using the analyze index command. You can do analyze index validate structure, which was originally designed, obviously, to make sure index was correctly stored. There was no corruption. But one of the things we do while we do that validate structure command is we populate these 2 columns in your index stats: optimal compression count and optimal compression % save. Optimal compression count tells you what is the best number of columns to compress. Is it the first column or the first 2 or the first 3, etc.? And if you do that, how much space will you save in your index? So the information is now calculated for you, and it's very easy to use. Now, you might be thinking, analyze index, validate structure will lock the index. And yes, it will. But of course, as I said earlier, you have a perfect candidate in which to run these commands on. Your standby database, which you open in read-write mode, analyze index validate structure on all your indexes to get this information, and then put it back into read-only mode. That's one of the cool things of having a standby. Let's wrap it up because we've got just 1 minute left. I can't stress enough here. I want people to steal each other's ideas, right? Poaching ideas from your colleagues is a good thing because the more we share our information within the community, the better a community we make. That's the idea. It's just simply a non-productive use of time for every single person to have to solve the same problems. That's one of the joys of Twitter, I think. And as I said, please follow me on Twitter. If you have problems, throw them on the community forums, throw them out on Twitter as well, saying, I'm trying to do this, can someone help me? If you get solutions from Twitter, what you should do then is build a little presentation like this one and give it in your own office. Give it at your own user group meeting. Rest assured, user group meetings are easy to attend nowadays because they're all virtual. So there's no more excuses of saying, oh, I don't like standing up in front of my group of users. You don't have to anymore. You just have to jump in front of a PC. And the best thing is, every time you do that, you've learned something new and you pass that on to others and they'll learn something new as well. And the total sum knowledge in the entire community just continues to grow. So as I said, please stay in touch. Hopefully you've found a lot of value in these tips. You can reach me on Twitter or follow my blog, and obviously get in touch over on YouTube as well. But I'll stop my share, and I'm out of time, but I'll take note of these Q&As that have come in, and I'll answer them via Twitter or via a blog post. And it's nice to finish there with a lovely coastal view of Uruguay. So Edelweiss and Nelson, if you're watching, shout out to you. I wish I was there in that lovely sunshine. But until then, until we meet in South America at some stage, or you're welcome to come visit us in Perth. Thank you very much for your time. Have a great, for me, it's a great day on Tuesday. For you, have a great rest of the evening. And I'll obviously see you on some of the sessions as an attendee through the rest of this fantastic groundbreaker event. Bye for now, everybody.
Yeah, thank you very much, Connor. We have, I think, a couple of minutes, and there are a couple of questions. So maybe, if you don't mind.
Yeah, sure.
We can...
Okay.
Okay, so I will translate you the one which is in Spanish, which says, okay. Aníbal is asking, in Oracle 19c, the new feature to use automatic indexes, if SPM should be enabled for that to work. And of course, the other part of that is if it is not affecting the performance of the insert updates on the tables.
Okay, no worries. Let me answer that one. Thank you for translating. Otherwise, I would have stared at that one. So let me talk off the inserts updates first. It's funny how whenever we talk about indexing, everyone always says, "Oh, but if I add an index, it's going to hurt my DML. It's going to hurt this, that, and the other." And this is true. There is a cost, but I would be willing to bet that in any time you have added an index in an emergency situation, no one I ever know of has gone, let me consult the redo consumption. Let me consult the DML overhead. It can happen, but it's very, very rare. 99% of the time, I think most people just throw on indexes because they have query problems. And our automatic indexing is a reflection of that. I think if we're going to be honest with ourselves, that's what most of us do. Now, don't get me wrong, there is definitely an overhead to adding in indexes, but automatic indexing, I think, is no different to what we've always done in the past. Now, in terms of the first thing, in terms of SQL plan management, one thing I don't know is if you have explicitly disabled SPM, then whether we will still use it from automatic indexing or not. But assuming you haven't, assuming it's just running as its default, the way we use SPM is, let's say I've got 10 bad SQLs that automatic indexing has identified to put an index on. It might say, okay, I'm going to add this brand new index on this table, and it might help 6 of them. 6 of those SQLs might get dramatically faster, but 4 of them might get worse. As I said in the invisible indexes tip, I said, it's a bit of a worry if adding an index makes something better, but other things worse. How does automatic indexing tackle that? What we do is for each query that gets worse with a new index, we find the plan that it was using without the index, and we use SQL plan management to lock that plan in place. In that way, when the new index comes along, it won't use any plan for that new index. Now, because it's SQL plan management, it will still capture that plan, so you can look at it later and evolve it if it actually does benefit. But one of the joys of automatic indexing is we can almost make a guarantee that we will only activate indexes, but only queries that get better will use those indexes. Queries that would have got worse will not see that index because SPM will be used to make sure they can't use that plan. And that's one of the benefits there. And one of the big design goals of automatic indexing is we will never make a query run slower. And that's obviously one of our key objectives. Okay, how is clustering compatible with partitioning? I'm assuming you mean the attribute clustering we spoke about. That works as well. You can do it at the partition level or at the table level. And the last question is, does index compression require the advanced compression option? No, we have 2 kinds of index compression. The one we saw in the tip there is called basic compression, and that is available in your normal editions of the Oracle database. There is also advanced index compression, which is a more robust compression in the sense that we will actually try even get more value out of the compression. And it's in the same ways as we have basic compression for tables and advanced compression for tables. Anything with the word advanced in front of it is where you have to get into the compression license. But the compression tip I showed you there, just with the compress 2, compress 1, you don't need any additional licensing for that.
Okay, and that was all. Thank you very much, Connor, for your time and for sharing with us in these strange conferences that we are having these days. But well, hope to see you next year when all things go back to normal.
No worries. Thanks, everyone. Thanks for joining, and yeah, have a great rest of the event.
Bye-bye.